In this video, we are going to solve a problem on resultant force analysis in a coplanar concurrent force system. Okay. So this is the problem statement. Three coplanar forces are acting at a point as shown in the figure. One of the forces is unknown and its magnitude is denoted as P in the figure. The resultant force of this system has the magnitude of 500 Newton and is acting along the positive y-axis. Determine the unknown force P and its inclination with the x-axis. So in the given problem, three concurrent forces and they are coplanar are being considered. So it is given in the problem that the resultant force of the system has the magnitude of 500 Newton and is acting along the positive y-axis. Okay. So usually resultant of a coplanar concurrent force system can be calculated using the formula R is equal to root of summation H square plus summation V square. So to calculate the magnitude of the resultant force, we require the summation of all the horizontal forces acting in the system and summation of all the vertical forces acting in the system. So problem enna kuduthirukanga appadina resultant oda magnitude 500 Newton is acting along the positive y-axis. So idhula irundhu enna infer pannikalam appadina summation V அதோட வேல்யூல தான் ரிசல்டன்ட் இருக்கு. ஸோ சமேஷன் எக்ஸ் இங்கே 0 அப்படிங்கிறத இன்ஃபர் பண்ணிக்கலாம். பிகாஸ் த என்டையர் ரிசல்டன்ட் ஆஃப் த சிஸ்டம் இஸ் ஆக்டிங் அலாங் த பாசிட்டிவ் ஒய் ஆக்சிஸ். ஸோ தெர் இஸ் நோ ஹரிசாண்டல் காம்பனன்ட் ஃபார் த ரிசல்டன்ட் ஃபோர்ஸ். ஓகே. ஸோ சமேஷன் ஹெச் இஸ் 0 அண்ட் சமேஷன் வி இஸ் பிளஸ் 500 நியூட்டன். So to solve the problem, we have to consider the three forces given in the coplanar concurrent force system one by one. Okay. So first considering the force of magnitude P acting in the first quadrant. Okay. So this force can be splitted into two force components. One along the horizontal direction, that is in the positive x-axis direction with the magnitude of P cos theta, and another one force component along the positive y-axis direction with the magnitude of P sin theta. So the horizontal component for the first force we are considering in the problem can be represented as Fx1, which is plus P cos theta because it is acting along the positive x-axis, and the vertical component of this force is plus P sin theta because it is acting along the positive y-axis. Next, considering the second force of magnitude 775 Newton, which is acting along the negative x-axis. So there is no vertical component for this force. Fx2, the horizontal component of this force, is minus 775 Newton because it is acting along the negative x-axis, and there is no vertical component for this force. So Fy2 is 0. Next, considering the third force acting in the fourth quadrant with the magnitude of 800 Newton and the horizontal inclination 20 degree. So this force can be splitted into two force components, one along the positive x-axis with the magnitude of 800 cos 20 and the other component along the negative y-axis with the magnitude of 800 sin 20. So Fx3 is plus 800 cos 20 and Fy3 is minus 800 sin 20. So we can now calculate the summation of all the horizontal force components acting in the system. Summation H is P cos theta, that is the horizontal component for the first force we are considering, minus 775. This force is acting along the negative x-axis. Then plus 800 cos 20, this force is acting in the fourth quadrant, that's horizontal component is plus 800 cos 20. So in the problem it is given that the summation of all the horizontal forces is 0 because the resultant is purely acting along the positive y-axis. So this summation H can be equated to 0. So we can get this relationship equation as P cos theta is equal to 23.2459. So we can have this expression as equation 1. And now we can calculate the summation of all the vertical forces acting in the system. So summation V is P sin theta minus 800 sin 20, because for the force acting along the negative x-axis there will be no vertical component. So summation V is P sin theta minus 273.6161, and from the problem statement the condition is summation V is resultant force, that is 500 Newton. So we can have the relationship for P sin theta as 773.6161 is equal to P sin theta. We can have this equation as equation 2. So equation 2 is P sin theta is equal to 773.6161. Equation 1 is P cos theta is equal to 23.2459. So our objective is to find out the value of the force P which is acting in the first quadrant and its horizontal inclination theta for the given condition. Okay. So now from these two equations we can calculate the values of P and theta. So for that, divide equation 2 by equation 1. So P sin theta by P cos theta is equal to 33.2799. So P and P will get cancelled. Sin theta by cos theta is equal to tan theta. So from which we can calculate the value of theta as 88.28 degree. Okay. So by substituting this value of theta in either equation 1 or 2, we can get the value of theta as P as 774.4721 Newton. Okay.